We're still on rationalizing the denominator of surds. In the last video clip, we looked at the conjugate concept. Throughout this video clip, we're going to look at how to rationalize a surdic expression in which we need to use the conjugate pair of the denominator. On the screen are the conjugate pairs that we considered in the last video clip. So let's proceed and see the questions we said we were going to treat in this clip. Immediately, let's look at this. Yes, in the last video clip we had these questions 1, 2, and 3 that we'll treat them in this clip. I think we'll look at questions 1 and 2 in this particular video, and then in the last video clip we will look at question number 3. First question says that we should rationalize the denominator of the following expressions. The first one states that 1 is what? 2 all over 3 plus the root of 5 is. Why do we call this expression one that needs to be rationalized? If we look at this, the denominator has an irrational number, even though we have 3 being rational. Since root 5 is an irrational number, then we say that the whole of the denominator is irrational. So we need to rationalize this. Unlike the first set of expressions we rationalize, remember when we had something like 1 all over root of 2? Then we said to rationalize this, we simply do what? Multiply the numerator and the denominator by root 2. That is the same value you have in the denominator. This does not hold in all cases. I'm going to erase this for the purpose of space. Let's take this out. Okay. In this case, root 5, of course, is our irrational number. That makes the entire denominator irrational. We can't just use root 5 to rationalize this denominator. It will not work. You can try it yourself and see. You will still arrive at an expression where the denominator will be irrational. So what do we do in this case? Where we have the denominator as a composite expression, say 2 parts, A and B, where one part, either A or B, or even both parts, are irrational. What do? We make use of the conjugate of that denominator. Since it is plus right now, we use minus. If it had been C minus D, then this would have been C plus D. Remember, C, D, one of them must be irrational, at least. Okay, so I wipe this out, and let's apply that in solving question number 1. That's number 1I. Question number 1I says, let us rationalize the expression 2 all over 3 plus root of 5. We say, oh, this is a composite expression. What do? We're going to multiply both the numerator and the denominator by the conjugate of 3 plus root 5. And I'm sure you will agree with me if I said the conjugate is 3 minus the root of 5. Yes. And I also say, okay, I'm going to use that same number or that same expression to to multiply the denominator, which means I have done nothing because I can simply cancel this out, which is still 1, which means I have not altered the expression 2 all over 3 plus root of 5. I just want to express it in a better way by making sure that the denominator is not an irrational number. So we set out. We say 2 times 3 minus root 5. Let's take it gradually. 3 minus the root of 5. And then the denominators will multiply themselves out also. 3 plus the root of 5 times 3 minus the root of 5. That's all. By the time we do this out, we find out that the denominator will become a rational number. Let's try and see. 2 times 3, I remember, is still 6 since I was in nursery 2. 2 times root of 5 still remains that. Sorry, I've forgotten to place my 2 there. 2 root 5. My 2 is refusing to stand. Let's do some little bit of erasing. Okay, we'll do that again. 6 minus, because we are multiplying a negative number there, 2 root of 5. Fine, I think my graphics tablet is happy with that. Now let's multiply this out. 3 times 3, you will agree, is 9. 3 times negative root 5, you will agree this will be minus 3 root of 5. Plus root 5 times 3 will give me positive number there. But both of them are positive. 3 root 5. And root 5 times root 5, you will agree is going to be 5. But positive number multiplying negative number, that should be negative. Sorry, this is not too neat. Let's move on to see how we can do this sweetly. So that's the beginning there. So you can see 2 all over 3 root 5 being rationalized by using the conjugate of the denominator to multiply both the numerator and the denominator. What is the conjugate? Simply change the sign that connects the two terms. So here we change plus to minus. 2 times 3 minus root 5 gives us the expression here. And then multiplying the two denominators there, we have the expression here. Expanding this, we have 6 minus 2 root 5. And expanding the denominator, we have 3 times 3, 9. 3 times negative root 5 there. Plus root 5 times 3, okay. And then root 5 times root 5. Root 5 times root 5 is 5. And positive and negative will give us negative. You will agree this one will cancel out. Yes, minus 3 root 5 plus 3 root 5, simple algebra, that will be 0 root 5. So there's no more root 5. So we proceed and say, therefore, this is what? 6 minus 2 root 5 divided by what? 9 minus 5. Because this one is gone. 0 root 5. So 9 minus 5 is what? Is 4. You may leave it that way. But I think I can do some simplification here. Why? I can see that 2 is common here. And I can take care of 4 also. I say 2 out. That gives me 3 minus root 5. It's not compulsory you do this, depending on what the examiner requires of you. This is 4. So I take a 2, take care of this. And 2, take care of this. That gives me a 2. That gives me a 2. This is 1. So our final answer, you will agree, sorry. Let's write this. The final answer is 3 minus root of 5 divided by 2. That's it for the first question. I think we'll run faster by the time we get to the second question. But for now, let's write this out neatly. Next slide. There we are. We can see that's the first thing. Multiplied up and down by the conjugate. Then numerator multiplication gives us that. Denominator multiplication gives us that. This cancels out at 0 and we have 9 minus 9 minus 5. And here we are. Okay, that's the factorization there. Just to do some simplification. And that gives us this. Wonderful. I'm sure you'll agree with me that we can advance to the next problem. Here we are told that root 5 divided by root of 3 minus 3 should be rationalized. The denominator should become a rational number. So, okay, that's not too much of a problem. We follow the same procedure. We can see that the denominator that you are trying to rationalize is a composite term made up of two terms. So you have to use what? We have to use its conjugate. So conjugating root 3 minus root 2 minus 3 will give us root of 2 plus 3. Again, same conjugate is used to multiply the denominator, root 2 plus 3. Bam! So we are there. And then we start our multiplication. Root 5 times this. Let me take it step by step so that you don't get angry. This is root 2 plus 3. That's the numerator multiplication. Let's go to denominator multiplication. Root 2 minus 3. Very soon I'll show you a shortcut. Instead of doing all this denominator multiplication, anytime you are multiplying denominators where the two of them are conjugates, you don't necessarily have to go that long distance. I'll show you that very soon. Now root 5 times root 2. If we can still remember right from our first, root 5 times root 2, same thing as root 2 times 5. That is what? 5 times 2. That gives us 10 roots. So root 5 times root 2 is root 10 plus root 5 times 3. Oh, it's 3 root 5. That's okay with the denominator. So with the numerator, the denominator is root 2 times root 2 will give me 2. Just like root A times root A will give us A. But we have root 2 times positive 3. That will give us 3 times the root of 2. Again, we have minus root 3 times root of 2. That will give us minus 3 times the root of 2. And minus 3 times plus of 3. That gives us minus 9. Please take note again that here we have positive 3 root 2, negative 3 root 2. This will become 0. Now this is always the case anytime we are multiplying conjugates. And the reason is because if you look at this, this is like A minus B, A plus B. From our basic algebra right from nursery 1, that's where I learned mine. Do not be angry if you got to learn yours in the secondary school. When I have an expression of this sort, we call it difference of two squares. So which means it's the same thing as just squaring A and subtracting the square of B. Which means squaring A means squaring root 2, which gives me 2, and squaring 3, which gives me 9. So which means I don't need to bother about this at all. Plus 3 root 2 minus 3 root 2 will give us 0. If we remember earlier, we had the same thing. Let's go back some few slides and see what happened there. So okay, this is just enough. You can see here, then we used 3 minus root 5 as the conjugate. Now when the denominator was multiplied, there we had 9, which is 3 square. We had 5, which was our root 5 square, which was like if I had taken this as my A and this as my B, then the rule says just do what? Square A, square B, subtract the 2, because this middle one will always cancel out. And that's exactly what we had here. 9 minus 5. Please, if you understand that very well, please always apply that and avoid spending so much time writing out this middle expression. So here we are going to have 2 minus 9, and we forgot about that, will give us minus 7. Our page is covered up, so I move to the next slide. Here we are. Multiplication of these two, which is our A minus B, A plus B, which we have just agreed it should just be A square minus B square. Don't trouble yourself. A square right now is 2. That's root 2 square. And then minus 3 times plus 3 gave us this. Or 3 times 3 rather gave us 9, and then we have a minus. And then this becomes 0. Which means we are going to have what? We're going to have this as root of 10 plus 3 root of 5 divided by, why bother myself, 2 minus 9. How? Square this, it gives you 2. Square the second one, it gives you 9, and subtract. That's A square minus B square. Don't bother yourself with the middle term. But if you don't mind, If you think you want to go through it, you are free to go through it. That's just for those who want to be faster. And then we'll move on. So we have 2 minus 9 there. 2 minus 9 there gives us what? Minus 7. So that's where we are. Minus 7. And then, of course, we just factorize minus out. Is it even necessary? It's not necessary. That's a total error. Please forget about the brackets. That's a mistake. So we end here. So that's it. Rationalizing this denominator, root 2 minus 3 give us a minus 7. And the numerator changed to this. So we have rationalized that expression. We move to the next question. The next question says we should rationalize this. 2 root 3 plus root 5. Root 3 plus 4 root 2. Do not bother yourself with the numerator. When we are rationalizing, we are just looking at what? We are looking at the denominator. So I'll go straight and say that I'm going to multiply the denominator and the numerator. Again, this is a composite expression, so I'm going to use the conjugate. I'm going to multiply by root of 3 minus 4 root 2. That's a conjugate. And I do the same thing to the denominator. Root of 3 minus 4 root 2. I'm sure you can carry out this expansion. Let's not bother ourselves so much. That's it there. That's the expansion there. Please just try and follow up. I'm going to explain how we have gotten that. Now this, that's the conjugate. That's the denominator. We have the conjugate up and down. To expand this, we have 2 root 3 times root 3. You agree root 3 times root 3 will give us 3. 2 root 3 times root 3. Root 3 times root 3 will give us 3. So 2 times 3 is 6. Okay, that has not been done yet. So we are going to have 6 there. And then 2 root 3 times 4 root 2. 2 root 3 times 4 root 2. 4 root 2. 2 times 4 is 8. Then, sorry about that. Please, let's hold on a bit. Okay, we're back. This is root 3 times root 2 will give us root 6. So that will give us minus. Why? Because this is positive. The 2 root 3 is positive and this is negative. So I have 8 root 6. And then we continue the expansion. This time around with root 5. Root 5 times root 3, you will agree to give us root 5 times 3, which is root of 15. Root 5 times minus 4 root 2. Root 5 times minus 4 root 2. Of course, the 2 square root signs will multiply to give us root 10. And minus 4 will be there. So we have minus 4 root 10. Divided by, we are done with the numerator, we go to the denominator. As I have said earlier on, these two are conjugate pairs. Just square this and subtract. If I square root 3 square, that's my a square, and I square 4 root 2, that will give me 3 minus 4 square is 16, root 2 times root 2 is 2, so that's times 2. I mean, I'm going to have 3 minus 32. But if you want to go to the whole length, no problem. But I'm simply telling you that this is going to be what? 3 minus 32. Let's move to the next slide and see that. That's it there. You can see that if you're going to go through the whole length, you have root 3 times root 3 giving you 3. Root 3 times 4 root 2 giving you 4 root 6. 4 root 2 times root 3, positive there, give you again 4 root 6, and then multiplying these two gives you the same thing we got before, minus 16 root 2. Look at this, this becomes 0, and then we finally arrive at 3 minus 32. Why bother ourselves always with this? Just square this and square this. Difference of 2 squares. Remember all the time, difference of 2 squares is simply a minus b, a plus b. It's something that occurs a lot in mathematics. So anytime we find something like that there, we just say, oh, this will be root of 3 square minus 4 root 2 square as my a square minus b square. I think I've made mention of this enough. I'm not going to talk about that anymore. So let's advance. There we are. There we are. 3 minus 32 gives us minus 29. And we look at the numerator. We cannot simplify any further. We can't break this down to give us any sort of numbers that we can pair up or find the square root of any other one. So we leave it at that. Please forget about this. This is an error. Okay. Sorry, it's not really an error. We just simply multiplied up and down by minus. So we change the sign of the numerator and change this to 29. Doesn't necessarily, it's not necessary, it's not very, very necessary there. So you will agree with me that rationalizing this expression gives us this, and we now have a rational number 29 or minus 29, whichever one you want to use to represent what the denominator, and our objective has been achieved. We're told to rationalize the denominator. The numerator can remain irrational. There is no problem about that in mathematics. Question number 2. We are asked to simplify this. We are going to rationalize this, but we have been told that when we rationalize this, we should try and express it in this form: a plus root of b. Excuse me? So let's set out to rationalize this. We'll speed up a bit. I'm sure we are all up to speed now. That's root 3 minus root 2. What do? Multiply the numerator and denominator by the conjugate. And the conjugate, of course, means I change my minus to plus of the denominator. Sorry, I've made a mistake there. That's 2. And then root 3 plus root 2. If I multiply this out, 3 root 3 times this, root 3 times root 3 will give me 3. Then times this 3, that gives me 9. Yes, you don't agree? That's it there. You want to slow us down? No problem. This is my 3. My root 3 times root 3 gives me 3. So that's 9. Sure, you're happy now. Now, 3 root 3 times, please, there's no minus there. 3 root 3 times root 2. This is a plus. This is like, say, 3 times the one that is out there. That's 3. And then root 3 times root 2 will give me what? Root 6. Yes, I'm sure you know that. Because this is the same thing as saying root of 3 times 2. So we have obtained our numerator. Denominator, again, we have a minus b multiplying a plus b. Please, let's not waste too much of time. That will be the square of root 3. That's 3. The square of root 2. That's 2. And then we subtract. Let's move on. So that's it there. And what do we obtain? You can see we have obtained this. That's where we stopped. And we have 9 plus 3 root 6. But remember, our question said that this thing should look like this: a plus root b. But now we have something out here, so we have to transfer it inside. Doing that, if 3 is going to go in there, it's going to become 9. That's to square it. And then 9 times 6 will give me 54. And that's exactly what we are having here. This was already 9, so that's there. So this 3 becomes root of 9, which is our 3, multiplied by 6. That gives us 54. So now we have been able to express this as what? A plus root of b. So our A is 9 and our B is 54. I'm sure we are all happy with this. If you're not too good, why don't you just take it from the top again? Next video clip, we're going to look at question number 3. And that's it. Question number 3. Wonderful question. Very interesting. We're going to treat question number 3 in the next video clip. Please do not run away. I expect you to move straight to the next video clip. Let's solve this together. But if you're tired, no problem. You can always join us later.